Good morning, everyone. My name is Keyan. I'm a PhD student from University of Buffalo. Today, I will discuss our research paper named as Moderating Illicit Online Image Promotion for Unsafe User-Generated Content Games using Large Vision Language Models. Many thanks to all the collaborators from UB, UTSA, Clemson, and EU. Before we start, I must remind you that this presentation contains sensitive images that could be disturbing to some members of the audience. Let me first briefly introduce what are user-generated content games, which we call as UGCGs. UGCGs are video games that allow players to create, modify, and share their own generated content, such as characters, avatar, building, and items. I believe most of you have heard of some games like Roblox, Minecraft, those kind of games, we call them as UGCGs. So recent years, UGCGs are increasingly popular. Roblox, one of the most popular UGCG platforms, has experienced continuous growth in its online use base. And in the middle of 2023, there were already over 65 million daily active users. However, as a game for all age players, Roblox is actually dominated by young users. According to the data from Statista, by the end of 2023, there are 58% of its users were under 16 years old. And 42% of users under 13 years old, which means they are children. However, not all the UGCGs are good for children to play. As some news and articles here, there are many unsafe UGCGs that contains sex, violence, scams, or bullying behaviors. Moreover, in our study, we found that there are many illicit promotions of such unsafe UGCGs online, such as examples here. These promotions are prevalent on social media platforms such as X, Reddit, and Discord. Also, these illicit promotions always use unsafe images, mainly screenshots from unsafe UGCGs with some benign text, such as, "We have an interesting game, please join us soon." Well, the problem here is that these images, they are really moderated, such as being blurred out or warned by the platform, such as other sensitive images. And unfortunately, by reading many discussions and stories online, we have confirmed that many children were recruited in such games by these kind of promotions. So to understand these images, we decided to collect an image data set. We first collect image tweets from X by using some hashtags identified in self-reported stories from Common Sense Media, which is a well-known platform that allows children and their parents to share their experiments and reviews for different games. And we gathered more than 38,000 tweets with images, and among them, we're annotating 4,000 randomly picked images. And at the end, around 3,000 valid UGCG images were conducted, including 1621 image classified as sexually explicit, over 200 as violent, and 1101 as safe. With the new data set, we first want to investigate whether existing unsafe image detectors can identify such unsafe images from UGCGs. So we randomly select 1,000 images from each of 3 different sexually explicit image data sets: real-world images, animated images, and also our UGCG images. So then we tested them with 5 state-of-the-art unsafe image detectors. In this table, we can see that all the detectors perform well in the first 2 data sets, which means they can easily detect real-world sexually explicit images and also those cartoon-style images. However, none of them can really get good results for those unsafe UGCG images. This experiment underscores the challenges in the detection of unsafe content within UGCGs. We found there are two major challenges in detecting such content. First, we have limited training data. There is no large-scale training data set of unsafe UGCG images that can be used by those existing detectors. Second, complex context. These unsafe images are very different from those traditional unsafe images, from the background environment to the characters. For example here, such images have artificially rendered 3D avatars with different features. For example, like the animal styles. Also, actually, we have some styles like the character has a head such as a rocket or some of those kind of styles. Also, they have abstract geometric representations like 3D blocks stitched together to form the human-like body. To address such challenges, we utilize large vision language models. Large vision language models are built based on large language models and can understand images with human language instructions. Large vision language models can easily address the challenge of limited training data with their zero-shot or few-shot learning capabilities. And for the complex context challenge, we can explore large vision language models' reasoning capabilities to understand the different visual representations. Actually, in our work, we use two large vision language models. One is an open source model, InstructBleep, and the other one is well-known, the GBD. To address such challenge, we built a new framework. We call it as UGCG Guard. It contains 4 components. First, images from social media platforms are collected and annotated. Then we design the chain of thought reasoning-based prompting strategy, which consider both domain adaptation and contextual identification. In the third part, large vision language models will take the prompts and those images as input and output answers for each question. Based on those outputs, the final decision will be made, like either the image is safe or not safe. In the end, this approach can be directly deployed by those social media platforms to protect those users. For designing a novel chain of thought reasoning-based prompt strategy, UGCG COT here, it can guide the model in understanding UGCG images step by step. First, we have a condition prompt that enables the model to understand that the given image actually was generated from games instead of the real world. Then the model will look into those images and try to find a subject with our first question. Next, to understand the unsafe content, we first design 3 sub-questions to prompt the model check if there's any sexually explicit content. Similarly, we have 2 questions for identifying violent content. The last step is to ask the model again to double check whether there are any other harmful activities, such as smoking or drugs. In the end, the model will look back into all the previous answers and make the final decision. Now let's take a look with some evaluation results. We first compared the performance of UGCG guards with the 3 baselines: Google Vision AI, NSFW CNN, and InstructBleep with only very simple prompt by asking if there's any unsafe content in those images. As shown in this table, actually only our UGCG guard can perform well in this task, and it achieves with 0.94 accuracy and F1 score. Here's an example that shows our approach compared to other methods. And actually, you can see the first two methods, they cannot really detect those images effectively. But ours, with the reasoning process, the model can understand the content and give the correct answer. Another interesting evaluation is to test UGCG guard in a real-world scenario. We conducted an in-the-wild experiment by testing it with UGCG images collected from Reddit and Discord. By testing around 400 images, we can see UGCG guard with different large vision language models can perform really well for both of those data sets and outperform all other models. Actually, we did a very comprehensive evaluation for our framework. However, due to the time, I will not list all of them and give those results here. So if you're interested, please check our paper through the first QR code. And our code and data sets are also available online. You can easily find them via those other QR codes. Thank you for your listening. I'm happy to answer any questions you may have.
Okay.